three particles are joined together by a thread as shown in the figure. All the three particles are moving along a smooth horizontal plane about a center point O. If the speed of the outermost particle is V0, then the ratio of the tension in the three sections of the particle will be equal to. Now if I consider these three particles and if I divide it along a straight line, this is the first particle, this is the second particle, and there is a third particle over here, and this is the center O. So basically on the third particle, now three particles of identical particles, okay, now three particles are identical, it means that mass of all three particles are same. So on the first particle there is only one force which is acting inwards, that is the tension force, let it be equal to T1. So and its distance from the center point O will be equal to, if this length is L, this length is L, and this is also L, so it will be equal to 3 times L from the center particle. So basically tension will be equal to the centripetal force, so T1 will be equal to m omega square r, which is equal to m omega square into 3L. Okay, let this be the tension in the first particle. Okay, now the tension in the, now we have to find out the tension in the second string. So for the second string, the same T1 will act in the right hand side direction. There will be one more force T2 in the left hand side direction. So if you see, this is the total free body diagram of the second particle M, and the resultant is inwards. Now obviously T2 will be greater than T1 because the resultant, that is the centripetal force, is towards the center, that is towards the left hand side. So it will be equal to m omega square r. Now over here T2 will be equal to T1 will be shifted on the right hand side. So m omega square r, now the r over here, this distance will be equal to 2 times L, it will be equal to 2L plus T1. So basically it will be equal to T1 is equal to m omega square 3L. So basically it will be equal to m omega square into phi L or phi ml omega square. Now let us concentrate on the third mass. The same T2 will act over here. There is another tension T3 on the left hand side. So basically this becomes the free body diagram. So over here T3 minus T2 will be equal to m omega square r. So now over here T3 will be equal to m omega square r. The distance of the first mass from the center is equal to L. So m omega square L plus T2. T2 is given as phi m omega square L. So it will be equal to 6 m omega square L. Now T1 is equal to m omega square L. T1 is equal to, over here T1 is equal to 3m omega square L. T2 is equal to 5m omega square L, and T3 will be equal to 6m omega square L. So the ratio will be equal to 3:5:6, which is option number D.